In this video, we're going to be talking about the binomial theorem. One of the ways in which we can simplify the binomial theorem or expanding binomials is to have some knowledge about what's called Pascal's triangle. It's not the only name for it though, as it's been known throughout history and in different countries throughout the world. Lots of different names for the triangle. However, in our culture, on the western side here, we definitely refer to it as Pascal's triangle. In this triangle, we have a lot of rows. So each of the levels in this triangle is a row. We name the top row, row 0. A little weird to start with 0 and not 1, but that's what we do. We'll see why in a second here. So if you just name each row as you go down, we can refer to these rows, and I'll show you how in a minute. There is a pattern to filling in this triangle. Starts with 1 on top. The next row has 1 and 1. The third row here, called row 2, is where we start to see a pattern develop. We have 1, 2, and 1. And then this fourth row called row 3 maybe makes the pattern a little bit more obvious. We have the numbers 1, 3, 3, and 1 filling in that row. So hopefully you can kind of see this pattern developing where the cell below is the sum of the two cells connected to it above. So this was 2 because up above we had 1 plus 1. Here this is 3 because 1 plus 2. Here this is 6 because we have 3 and 3 above it. So if you use that pattern, you can fill in all of your rows and all of those little hexagon values there. Other patterns that you can see is maybe if you look diagonally, we see that each of these starting values is always 1, as well as all of the ending values. If you look diagonally down this second row here, on more of a diagonal column, I guess, it's just increasing by 1 each way. And if you go the other direction, you see the same pattern there. If you continue to go diagonally down this row, it starts to increase by a different amount each time. First it increases by 2, then it increases by 3, then 4, and then 5. And actually you can see how much it increases by just looking to the left in that cell. So I know that going from 1 to this next cell diagonally, I must be increasing by 2. Another example right here, if I go to the next cell diagonally, I look to the left, it's a 5, so I must increase by 5 there. Kind of goes along with that initial pattern of just adding the two cells directly above. So those patterns are probably enough to help you fill that in if you forgot or don't memorize each of these rows. Then you may have to just sketch it out real quick. Typically, most problems don't require us to go any higher than an exponent of 6, but if they did, we could use this triangle to help us with that. And here's how it helps us. When we expand a binomial by raising a binomial to some exponent, these cells in each row are going to tell us the coefficients for each term in that expansion. So for example, taking the quantity a plus b cubed, if it's cubed, I'm going to look in the third row of my triangle here. And the values 1, 3, 3, and 1, 1, 3, 3, and 1, yeah, that's what I said, are going to be the exponents, sorry, not the exponents, the coefficients in our expansion. So notice the 1, 3, 3, 1 as being the coefficients of each term. There is a pattern with our exponents though, and we'll talk about that next. Notice that each expansion is going to have n plus 1 terms. So whatever your exponent is, that's the n value. If you add 1 to that, that's going to be the number of terms in your expansion. So here we were cubing. So if we add 1 to that, we should have 4, and we can see 4 terms in that expansion. Another pattern involves the first term, the a term, as you might call it. It starts with an exponent given to us, that n value, and then it decreases and each following term. So a cubed, a squared, a to the first. Here would be a to the 0, and anything to the 0 power is 1. And if we're multiplying by 1, well then that's just the identity. We don't need it. So we don't include it. The second term, or the b term, is going to increase in power, or exponent. So here we're starting with b to the 0 power, which is not included. Then over here we got b to the first power, then we have b squared, and then b cubed. Also in each term, the sum of the exponents in your term is going to add up to whatever that initial n value or initial exponent value was. So here we have a total exponent of 3. Here we have 2 and 1 giving us 3. Here we have 1 and 2 giving us 3. And then here we have 3 matching that initial exponent. All right, so as we expand here, we're going to follow these patterns, and it's going to help us take some shortcuts rather than going the long way. In this first example, anything raised to the 0 power is going to be 1, regardless of how many terms are being raised. And that's going to match with the 0 row in our triangle, where we said we just have 1 as the coefficient, and we actually don't have any variables attached to it. If we take the quantity a plus b and raise it to the first power, well, that's just going to be itself. So we have coefficients of 1 and 1 corresponding with that row 1, where we had 1 and 1 in those cells. All right, the next spot is usually where I tend to see mistakes that students make. Common misconception: whenever we square a binomial, sometimes students like to say it's a squared plus b squared. Don't do that. We can use the knowledge in this lesson to remind us that that's not true. Anytime we square a binomial, that means we're multiplying it by itself. So we have a plus b times itself, a plus b. Because our exponent is 2, we should have 3 terms. Remember, our expansion should have n plus 1 terms. So that should help you remind you that this quantity squared, a binomial squared, doesn't have 2 terms, it has 3 terms. And then we know that our coefficients in that row 2 is going to be 1, 2, and 1. So we see those coefficients happening when we square or FOIL or distribute, however you like to simplify this, or expand it, sorry. A times A is A squared, A times B is AB, B times A is AB, so we have 2 ABs, and then B times B is B squared. The other pattern is that you can square the first term, double the product of the 2 terms in your binomial, so AB doubled is 2AB, and then square the last term. So there's another pattern you can use for squaring binomials. Notice that each term, the exponents added up to our exponent of 2. Here, a to the first and b to the first, those exponents add up to 2. All right, this is where it starts to get a little tricky and takes a little bit longer. If I have the quantity a plus b cubed, well, that means that I'm doing a plus b squared times another a plus b. So we already know that a plus b squared is a squared plus 2ab plus b squared. So if we distribute an a plus b to all of those terms, essentially multiplying everything by a and then multiplying everything by b, we get this result. Notice our coefficients, 1, 3, 3, and 1, corresponding with our third row in our triangle. We have 4 terms, which is 1 more than the exponent. The a terms of the first term is decreasing from our original exponent, 3, 2, 1, and then no a term. B is increasing from 0, 1, 2, and 3. And the sum of the powers in each term, 3 there, 2 plus 1 is 3 there, 1 plus 2 is 3 there, and another 3 there. So let's use that pattern so that we don't have to do this longhand way. We can use the shortcut for the next 3 expansions here. So raising it to the fourth power, we're going to look at our fourth row in our triangle here. We know the coefficients are going to be 1, 4, 6, 4, and 1. So I like to write the coefficients first and give myself some space in between them. I know that my first term, or my a term, is going to be raised to the exponent, so 1a to the fourth, and then I'm going to have a to the third in the next term, a squared in the next term, a to the first power in the second to last term there, and a to the 0, or just don't include the a in that last term. The second term, or the b term, is going to start with an exponent of 0, so it's not included, and then it's going to go b to the first, b to the second, b to the third, and then b to the fourth. Make sure that we have one more terms than our exponent is. Our exponent is 4, so we need 5 terms. We got that. And then make sure that each term's exponents add up to your original exponent. So we got 4, 3 and 1 is 4, 2 and 2 is 4, 1 and 3 is 4, and 4 is 4. So you can go ahead and finish off those last two using that pattern. Pause the video here if you want to check your work. All right, let's move into some more complicated examples here. This time we're going to include different letters or numbers instead of the A and the B. So we're going to use these patterns, and then we're going to substitute the values given in our new binomials. Also a little different here. Notice that everything we've practiced so far looked at has been a sum of two terms in our binomial. Well, what happens if it's a subtraction or a difference between the two terms in the binomial? We just have to think about that slightly differently. Think about it as addition. Subtraction is the same as adding the opposite. So instead of x minus 1, we just rewrite it as x plus negative 1. And now we have a sum, and now we can use all of these patterns that we talked about. So our first term is going to be x, or the a term. Our second term, or b term, is going to be negative 1. So let's establish the pattern for cubing the binomial. We're looking at the third row in our triangle. We're going to have the coefficients 1, 3, 3, and 1. We'll have our a term squared, no b term. Next we'll have our a squared term, and then a to the first term next, and then no a term on that last term. No b term in the first one. Start with b to the first power in the second term, b squared next, and then b cubed. So there's our pattern for cubing a binomial. Now all we have to do is substitute our first and our second term, or a and b values. A was x, so a cubed is now x cubed. Here, instead of a squared, we have x squared. Instead of b, we're substituting negative 1. So now we're doing negative 1 times 3, which is going to give us negative 3x squared. In our third term here, we have 3 times x. And this time our b term is going to be squared. So we're going to square negative 1. Negative 1 squared is positive 1. Positive 1 times 3 is positive 3. So we have 3x in our third term there. And then lastly, we're going to cube negative 1. If we cube a negative, it's going to stay negative. A negative times a negative is positive, but times another negative makes it negative. So squaring even exponents of negative numbers, like a square, gives us a positive result. And if we raise a negative number to an odd exponent, it's going to stay negative. So there's our final answer, final expansion of x minus 1 cubed. You can pause the video if you think you got it, or follow along with the next example. We'll still have one more after this. This time we're going to take the quantity 2x minus 3 and we're going to raise it to the fourth power. So we're looking in the fourth row in our triangle. We're going to use the coefficients 1, 4, 6, 4, and 1. We're going to start with our first term to the fourth and then decrease its exponent in each term. A cubed, a squared, a to the first, no a. Take that second term or b term, raise it to the 0, then increase b to the first, b to the second, b to the third, and then b to the fourth to finish. There's the pattern that we need to follow and substitute. Our first term or a term is 2x, and our second term or b term is -3. Again, changing the -3 to plus -3, giving that second term's value -3. Here's where a common mistake tends to happen. Because we have a coefficient in front of a variable here, we want to raise that whole thing, that whole term, 2x, is the a term. So we're going to raise 2x to the fourth, not just x to the fourth, but 2 to the fourth and x to the fourth. So 2 to the fourth is 16, and x to the fourth is x to the fourth. So we got 16x to the fourth first. Again, substituting 2x into the a spot here, we're cubing 2x. 2 cubed is 8. And then x cubed. 8 times 4 is 32. Our b term is -3, so we're doing 32 times -3. That's going to give us -96 x cubed for that next term. On to the third term. Substituting 2x, squaring it, that's going to give us 4x squared. -3 squared is going to give us +9, so 9 times 4x times 6 is going to give us 216x squared. Next term, we got 2x to the first power and -3 squared. -3 squared is 9. Sorry, that should be cubed. -3 cubed, hopefully I didn't make that mistake. -3 cubed is 27. 27 times 2 times 4, I hope, is -216. Yeah, that seems about right. So that just seems like a little mistake right there in my writing, not in my arithmetic. And then lastly, -3 raised to the fourth power. That's going to be +81. So we finish it off there. All right, there is another example. Again, feel free to pause the video and try it out on your own. You can check your work here. All right, we got one more example. What if we just want to find an individual term in an expansion? So for example, what if we wanted to find what is the third term in this expansion here? Well, what we're going to do is we're going to look at the fourth row in our triangle, and we're going to look at the third term to find its coefficient. So in our triangle, the fourth row, third term is going to have a coefficient of 6. We can think about what our a value is going to have an exponent of. It's going to have a to the fourth in that first spot, then a to the third in the second spot. So in this spot, it's going to be a squared. Let's think about our b term as well. In the first spot is b to the 0, so not included. Second spot is b to the first power. And here it's going to be b squared as well. So we got 6a squared b squared is our pattern. We can substitute now the values in our binomial. The first term is x, so we're squaring x. That's just x squared. The second term is 2, so we're going to square 2. That's going to be 4. And 4 times 6 is 24, so the final result of that third term is going to be 24x squared. One more example. Again, feel free to pause the video, try it out on your own, and check your work. Hopefully you're looking in the fifth row in your triangle, and you're looking at the fourth term for the coefficient. That's a 10. The a term is going to be to the second power in that fourth spot of the fifth row. And the b term is going to be b cubed, again in the fourth spot of that fifth row. X is going to be our a term, and if we add the opposite here, our b term is going to be -6y. So squaring x gives us x squared. Cubing -6y, -6 cubed is -216, and then it should be y cubed there. Another mistake, dang. All right, well, not a mistake in my final answer, just a couple mistakes in my work shown. Apologize for that. That should be y cubed. Putting that together, 10 times negative 216 is negative 2,160 x squared y cubed. All right, it's kind of complicated there. Use that triangle to help you with those patterns. And good luck expanding those binomials.